Hello everyone, I hope you're all fine and all right and having a good time and staying home safe. Right, so this is just my second lecture or second video from topic 14, the matrices, and on today's session I'm going to cover the inverse of a 2 by 2 matrix. Okay. The inverse of a 2 by 2 matrix, just to let you know, we don't need to know the inverse of a 3 by 3 matrices. Yeah, so on this module, we're only gonna cover the 2 by 2 matrix. Okay, so if we have a matrix, like this matrix here, A, B, C, D, just to remember that not all matrices can be inverted. If the determinant of the matrix is equal 0, then we can't invert that matrix. If the determinant is not equal 0, then we can be inverted. Right, so a matrix can be inverted if its determinant is not 0. So if that A not equal 0, then this can be inverted. That means we can have an inverse for it. Okay, so consider a 2 by 2 matrix like is shown below. Then its determinant, okay, how to find the determinant? The determinant is multiplying, or it's the product or the multiplying of this diagonal. So it's A times D. Yeah, so it's the product of the diagonal A times D minus the other diagonal, which is B times C. Okay, so the determinant of A is A times B minus B times C. Okay, if the value of this determinant is 0, we cannot find the inverse for that matrix. If the determinant is not equal 0, then that means we can invert it. We can find the inverse for it. Okay. Right, so if the determinant is not equal 0, then A is called a non-singular matrix. And if the determinant A equals 0, then it's called a singular matrix, and in that case we cannot find the inverse for it. If the determinant equals 0, cannot or can't find the inverse. Okay, right, let's see an example here. Find the determinant of the matrix A and state whether it is invertible or not. So as we said, to find the inverted, we multiply this diagonals, yeah, which is minus 2 times A 1 minus the other diagonal, the product of other diagonal, which is these two. So the determinant here for A equals minus 2 times 1 minus 8 times 3. So that's minus 2 times 1, which is minus 2, then minus 24, so this ends up as minus 26. When we say determinant A, it's not same as the modulus A. Yeah, maybe sometimes they will write it as modulus, but it doesn't mean it's a positive. It's the determinant of A in matrices. It can be negative. That's fine. So that A equals, you can write it down as this way, okay, but it's negative. It's fine. Okay, to be negative, it's fine. Okay, so because the determinant now, as we can see, that A is minus 26, which means not equal 0. Yes, therefore it is invertible. So it is invertible. Okay, that means we can find the inverse for it. Right, let's just clear this so you can have a look at the slide. Okay, so the determinant A is minus 2 times 1 minus 8 times 3, which is minus 26, and because it's not equal 0, so it's non-singular matrix. That means we can invert it. We can find the inverse for it. Okay, now how to find the inverse of a 2 by 2 matrix? As I said, we don't need to find inverse of a 3 by 3, so you don't need to worry. And also to find an inverse of a 2 by 2 matrix, as you can see, it's 2 by 2, so it's only a square. Non-singular matrices can have an inverse. So the conditions to have an inverse matrices, it has to be square. That means, like, for example, 2 by 2 or 3 by 3 or 4 by 4, whatever. Well, not 4 by 4, 2 by 2 and 3 by 3. And non-singular matrices, that means the determinant for it is not equal 0. Okay. The inverse of a 2 by 2 matrix is another matrix. So the inverse for it, it's another matrix. It's the result of, like, we do a few steps to find the inverse of the matrix. So it's different than A itself. So for example here, if we have the matrix A is the matrix A, which is A, B, C, D, then to find the inverse of A, of the matrix, we need to do an extra step from the determinant to find the inverse. So basically we will use the determinant of A to find the inverse of the matrices. So if we look here on this formula, the inverse is given by 1 over AD minus BC. So AD minus BC, it means these two, A times D minus BC. So this is the determinant, yeah? So A times D minus B times C is the determinant of A. Okay, so that means we need the determinant to work out the inverse. So this means it's 1 over the determinant of A multiplied by, this is another step here, and this matrix here. What we did here, we need to change or swap the diagonal. So if you look at the original one, there was A, B, C, D. Then in this one, it's been swapped. The places of A and D swapped over. So this becomes D and this becomes A. And also they change the sign for the other two elements. So this becomes minus B and this becomes minus C. Okay, and that's what it is here. So that's how to find the inverse. We need to find the determinant and we divide by the determinant and then multiply by this matrix after two changes, which is the diagonal swap over and the other diagonals change the sign for them. The inverse of a matrix has the properties of A times A inverse equals I. And same thing if A inverse, which means the inverse of the matrix multiplied by the matrix itself equals I. Okay, find the inverse of this matrix. Okay, so to find the inverse for this, we need to do a few steps. So to find an inverse, first of all, we need to find the determinant of it. Okay. So I'm just going to write down, like, the formula of the inverse is 1 over that A, yeah, and multiplied by swapping over. So there's going to be 0, 2, and changing the sign for the other two elements. And there's going to be minus 0.5 and this minus 1. Okay, so how to find the determinant? I'll say that determinant A in this case is going to be 2 times 0 minus 0.5 times 1. Okay, this is the original one still, and this is going to be equal to 2 times 0 is 0 minus 0.5 plus times 1 is 0.1. Yeah, sorry, 0.5. So it's going to be minus 0.5. Right. And for this matrix, we do some changes for it. Well, before that, therefore, determinant A in this case is not equal 0. That means, therefore, it can be inverted. Okay. Right. So the next thing to do is changing the other matrix. So what we need to do is change, as I said, we swap between we swap the places of these two elements of this diagonal. So this is going to be 0 and 2, and also we need to change the sign for these yellow ones. Okay, change their sign. So this is going to be minus 0.5 and minus 1. Right? And now we will do the apply this formula. So therefore, A inverse equals 1 over the determinant, which is minus 0.5, multiplied by this the matrix we changed, which is 0, minus 0.5, and minus 1 and 2. Okay, so that means it's multiplying minus 1 over 0.5. So just as a note for you, 1 over minus 0.5, it's like 1 or minus 1 over 1 over 2, which means it's like minus 2. Yeah, so instead of 1 over minus 0.5, we can write it down as minus 2. So A inverse is minus 2 multiplied by 0, minus 0.5, minus 1 and 2. And then, as we learned from the previous lecture, to multiply, all we need to do is multiplying the elements by the minus 2. So minus 2 times 0, minus 2 times minus half, and minus 2 times minus 1, minus 2 times 2. So this will give us minus 2 times 0 is 0, minus 2 times minus half, which means minus 2 times minus 1 over 2. Yeah, so it is minus times minus is a plus, so that's going to be 1. Right? And minus 2 times minus 2, that's plus 2, and minus 2 times 2 is minus 4. So this is the inverse. So then, therefore, A inverse equals 0, 1, 2, minus 4. And that's it. Okay? Right. So I'll just clear the screen and you can have a look at the slide here. Okay, So it's 0, 1, 2, minus 4, and that's it. Okay, so the summary for it, like square matrices have a determinant. If the determinant is non-zero, if dt, if that's A not equal 0, then can be inverted. That means we can find the inverse for it. If the determinant of A is equal 0, we can't inverse. Yeah, cannot be inverted. So you can't find the inverse for it. Okay. How to find the determinant is basically the diagonal, the product of the diagonal minus the product of the other diagonal. Okay, and I'm just gonna write some I'm just going to write the steps for you. If okay, I'm just going to write some notes, maybe if it's useful for you here. So to find the inverse of of a matrix, yeah, you need some steps to do. So say A equals A, B, C, D. So first of all, what we need to do, the first step is find the determinant of A, which is the diagonal, the product of the diagonal AD minus the product of the other diagonal BC. Okay? And then if the determinant of A is equal 0, then there is no solution. I mean, you cannot inverse that matrix. So if the determinant is A, you need to stop, as there is no inverse in this case. Okay, if the determinant of A is not equal 0, then you continue. That means continue to find the inverse. Okay, so after you find the determinant, what you need to do is we need to divide by the determinant. Yeah, so it's 1 over the determinant. So you need to have find 1 over the determinant A. Okay, and then after that you need to swap A and D. So the second step is swap A and D. Swap A and D, yeah, these two. Let's swap them over. Yeah, this go there, this come back here. So and also you need to change the sign of B and C, okay, which is this and this, B and C. So if they are positive, they will become negative. If it's negative, it will become positive, and vice versa. So And at the end, we should get as A inverse equals 1 over the determinant A multiplied by, as we said, there's going to be D, and this will be minus B here, minus C, and this is A. Yeah? D minus B minus C, A. Yes. And that's it. Okay? Well, I hope you understand this. Have a nice day. And if you have any question, please contact me. And thank you very much. I will give you some work to do for this as well. See you later. Bye.